Southwestern Ontario has historically been agricultural. It is a beautiful area to live near the water, but one thing that occasionally happens that could be disastrous for property and lives is flooding. Occasional floods have been recorded since the late 1700s. The flood of 1883, people had to think of a way to protect people in the City of London. The city built a series of dikes to protect property and lives. In April of 1937, the water that flooded London was a combination of melted snow and rain over several days. Floodwater went right over the partially completed dike system. In 1947, the Upper Thames River Conservation Authority was formed, an organization that's purpose was to protect property and lives from flooding and to conserve other natural resources for environmental benefits. Fanshawe Dam was built between 1950 and 52. The reservoir was created to store the extra floodwater. The Conservation Authority is constantly monitoring how much water is coming from the North Branch, which will determine if they need to raise one or more of the gates of the dam and to let the floodwaters through to the river into the City of London. Besides building flood control structures, CAs are now taking a more natural approach to minimizing the impacts of flooding, such as preserving our wetlands and reforesting our watershed.
So the Thames River watershed has approximately 24 stream gauge buildings, which are placed along the edge of the river and in various areas that make it easy to measure things like water flow, air temperature, and rainfall amounts. This information is gathered by the engineers at the Upper Thames River Conservation Authority, and it helps us to determine whether or not we should be raising or lowering the gates of the dam. When there is an excess of flood water coming over from Fanshawe Lake into the Thames River, it has to go through the gates of the dam. There are 6 gates on Fanshawe Dam. They are called sluice gates, and they weigh about 37 tons apiece. And when the gates are open, the water will crest through over the spillway, which is a curved piece of cement, and down into that first area of water that leads into the Thames River. Stilling Basin is the area where the water will sit for a little while. And what happens there, it loses some of its energy. So the energy dissipates from the water, and that in turn will reduce the amount of erosion that happens along the edges of the river. We have the wing walls on either side of the dam. So 2 large walls that are embedded right into the bedrock, so that is the very deep foundation of the dam in which it sits. And that also provides a bit of erosion control and direction for the movement of water. On the right-hand wing wall, there is what we call the low flow discharge valve. And that is in place for a couple of reasons. Certain times of the year, we have to create some more oxygen in the Thames River, so it aerates the river water as the water from the low flow discharge valve comes from Fanshawe Reservoir. It will increase the flow a little bit in the drier months, so those are a couple of reasons why that is there. We also have a very large tube on the right-hand side wing wall, and that tube is called the penstock tube. And that penstock tube actually takes water from the reservoir and it takes it right into the hydroelectric building. The hydroelectric building has been in operation since the 1980s, and water is directed into that building, and then it will go through 2 big machines. It will go through a generator and a turbine, and at that point we harness the energy from the water, and with that energy we make electricity. After the water is done being used by those 2 very large machines, then it will end up in what we call the tail race. And that's just a little area where, once again, the water will sit, and then before it becomes part of the Thames River again. So essentially, we're just borrowing the water from the river to create something magnificent such as electricity, and then putting it back into the river. The Upper Thames River Conservation Authority makes about enough electricity per year for about 300 households. The gates at Fanshawe Dam are opened and closed using a system of gears and pulleys. Along the catwalk, there are switches for each of the gates. Turning a switch on starts a motor which gets a gear system turning. So welcome to the inspection tunnel of Fanshawe Dam. The reasoning behind the inspection tunnel is to maintain and and to take care of any problems that may arise down here at this level. It also gives us access to the low flow discharge valves if they need any repairing. So when we started up at the top, at the roadway, this cross section gives us a nice overview of that. And so what we've done is we've come past the sluice gates. We went past a little tunnel halfway down, and then now we are in what we call the inspection tunnel. And that's about 88 feet below the roadway, 27 meters, and so it is quite down. If you look at the cross section here, we are in the clay loam overburden, and so there's not much to see. If we had a window here or anything, you wouldn't be able to see anything except dirt. So here we are at the far end of the inspection tunnel. This is where we notice these stalactites hanging from the ceiling. And so what we have here are the calcium that's leaching out from the concrete and making those lovely formations that hang down. And you will also see those types of formations in caves as well. So it's kind of interesting to note the similarities between being down here in an inspection tunnel and a cave. We also have a large hole in the ceiling. And that hole in the ceiling is there for airflow. So there's a fan up at the top at the roadway that will push down air into the inspection tunnel. So we all have something to breathe while we're down here. And it also does increase the humidity sometimes in the summertime, and so it does get very moist and damp, and that's what's also creating that cave-like atmosphere. Lastly, we have some very old equipment that was left behind by Western Ontario. In the 1960s, they placed some seismograph equipment. And that seismograph equipment will measure something down here at this level that's a little harder to measure up at the top. And what that is earth tremors. So we actually got some statistical data from them, and they told us that we actually measured approximately 200 earth tremors per year here in London. So that was very fascinating information for us to know and to pass along to you.